Hi guys. So we are going to be taking this whole Ka and Kb thing a little bit further now into talking about salts. Earlier in this unit we went over salts and how to decide if they were acidic, basic, or neutral based on their parent atoms. And the reason why we did that is that we can do equilibrium problems with those salts and figure out what their Kas and Kbs or pHs are based on whether or not that salt is acidic or basic. So there's going to be really three types of problems. We've learned the Kas for just plain old weak acids, and we've learned the Kbs for just plain old weak bases. But now we're going to add this salt dynamic to it. And again, the salts can either be acidic or basic. In this unit, we won't use any of the neutral salts, because if they're neutral, then there's no point in doing what we're doing. We know their pH is 7. But if they are acidic or basic, we can study that. Now, we're not going to actually get into the equilibrium part of this until the next lesson. But what I need to do with you today is to make sure that you understand all your equations, what equations you're writing in your table. So we're going to start, if you look on your notes, with actual acids and bases, which you've already done. You did these with your Ks and Kbs. But if you've been having any issue writing your equations in your tables for your Ks and Kbs, this is going to help you just kind of remember that whole process. For some reason, my smart notebook was missing when I went to record this, so I'm just going to do it on a blank slate. But you have in front of you the top part there says equations for acid dissociation. Remember, we said there's two ways to write it. You can either write it literally of the H plus splitting up into H plus and then whatever the anion is, or you can show water. And remember, the whole idea with showing water is that H pluses are going to be donated with acids. Acids always give away an H plus. That's why the H plus ends up floating around in the first equation. Or you can show it actually attaching to water to make H3O plus, the hydronium ion. That's technically what really happens, but you can do either one of them. So let's look at the practice problems, the examples. So you have HClO2, which is a weak acid, so we have a double-sided arrow. Now, again, the simplest way to do this would just be to say that it's going to lose its H plus, and then the other ion will be ClO2 minus, and that's what would have ended up on your table. You also could have done HClO2 plus H2O, okay, and said that this is going to donate the H plus, because remember, acids are proton donors, they're H plus donors, and it's going to make H3O plus and then ClO2 minus. And again, these two things mean the exact same thing because these two things are exactly the same. Okay, so either one of those is fine. I usually stick with this equation up here for acids just to make my life simpler, a little shorter to write, not as much to do. Let's look at the acetic acid, HC2, H3O2. So again, simplest way, I could just show it broken up. So into H plus and C2H3O2 minus, like so. Or if I want, if you prefer, with the salts and with bases, we have to show the water. So if you want to show the water all the time, remember it cancels off of your table because it's pure liquid water, so it's just going to cancel off your table. But if you would like to show it, you're welcome to. So it's going to transfer its H plus, and it leaves the anion, and then H3O plus. So that is the acid ones. Hopefully by now you're feeling pretty comfortable with those, but if you're not, this is a good part to review. Let's take a look at the bases. This is the last thing we did. We said with bases are H plus acceptors. We take the H plus from the H2O, and that's why we always have to show H2O in our equation. So for the first practice problem there, you see CH3, 3N. Okay, so the first thing you're going to have to do is identify that it is a base. Acids start with H plus, okay, and then bases we said was everything else except for our salts, which I'll show you how to find your salt, okay, in a little bit. So right now we'll call this a base. And again, they're going to look weird. They're going to be organic bases, very strange looking things. Most of the time they'll be big clumps of things. Just think of them as one big molecule and don't take it any further than that. You're not going to break it up. You're not going to do anything with it. What's going to happen here is bases, again, take an H plus from the water. So when they take an H plus from the water, one of the things that gets left behind is the OH minus. That's from the water. And then you're going to shove that H plus onto that molecule. And I told you with the weak base discussion that it doesn't really matter where you put it. I typically put it on the end, so if you don't care, I'd tell you to put it on the end, just so that it's easy for me to see that you did put it on there. If you're put it on the front, that's fine. Just make sure you're not just transferring a hydrogen, but also positive charge. Okay, so that's what that base looks like. And remember, they should always make OH minus if they're a base. This other one is going to be CrH2O5. This thing probably looks very bizarre to you, and that it should be. I mean, it's a really strange organic molecule, again, but you just look at it and say, okay, it's not an acid, so therefore it will be a base. And again, I got to tell you about the salts, but you'll be able to easily identify them. Okay, so if it's a base, it's taking an H+, transfers it over, you get CrH2O5OH. Now, before there was one H at the end here. Now I'm going to have two. Before there was a +5 charge. Oh, I'm sorry, I wrote that wrong, didn't I? This charge should be +2. So before there was a +2 charge, so now I'm going to make it a +3 because we had an extra positive. And then don't forget, the OH minus is always the other ion, and that's what makes it basic. So that part's a review. That part you are familiar with. Hopefully, if you weren't, then a little extra help for you. Now, the next part is the salts. Now, down at the bottom of your paper, there are directions on how to do what I'm about to do with you, and you'll have them on that paper. I do want to go to number 3 on the directions. Well, actually, let's just read through them real fast. So, it says, when you're given a salt, you must do the following things. First of all, how do we know it's a salt? By that salt, I want you to write yourself a note that if it's an ionic compound, then you are dealing with a salt. Okay, so you're going to look for something that starts with a metal and ends with a non-metal, or non-metals if it's polyatomic. Okay, so if it is ionic compound, it is a salt. That's what you are looking for. And don't forget, NH4 plus is like a metal. Okay, so you're looking for a metal or NH4 plus at the beginning of the compound. If you have that, then you likely have a salt. Now I say likely because if we go back to the last example that we did, you see this guy right here. This is clearly not a polyatomic ion. You see that it has a charge, okay, big, huge molecule like that, not a salt. But if you have a metal with a non-metal or a polyatomic, you're going to be dealing with a salt, okay? So once you decide you have a salt, you got to decide if it's acidic or basic, which we learned how to do the other day by breaking it down into its parent acid and base, looking at the combination. We'll review that in a second. Once you do that, if you decide it's acidic or basic, you're going to break your salt into its ions. That is not the equation for the table, okay? You have to take it a step further, because what happens is that salt breaks up into its 2 ions, and then the part of the salt that matters, whether or not it's acidic or basic, is going to tell us that. The part of the salt that matters is actually going to react with water, and that is the actual part of the reaction that makes it acidic or basic. So if you look at number 3, it says if the salt is acidic, so once you decide that it's acidic, you'll use only the cation. So you're going to break your salt up and pull the cation out. So circle maybe the words acidic and the words cation. Then it says if the salt is basic, maybe box in the word basic, then you only use the anion, box in the word anion. So if acidic, you're using the cation. If basic, you're using the anion. Okay, acidic, use cation, basic, use anion. And then you're going to react it with water, and I'm going to show you how to do that. So let's go ahead and flip to the back side so I can show you how this works. So our example we have here is NH4Br. So I look at this compound, I know it's an ionic compound because it starts with ammonium. Again, if it started with a metal or ammonium, and it's a simple compound, it's going to be a salt. So I first have to decide if this thing is acidic or basic. So just like we learned, we're going to break these up. The cation always came from something with hydroxide, and the anion you can always think of as coming from something with the H+, the acidic part. So NH4OH is a weak base. HBr is a strong acid. So we have a weak base, strong acid combination. That makes for an acidic salt. Okay, so I have now decided that my salt was acidic. So now I'm going to take and dissociate my salt. Notice this is a single-sided arrow because when you put salt in water, it will completely break up into its ions. This is not the equilibrium part. Okay, this part will completely happen. The NH4 will break up into NH4 plus and Br minus. Okay, only one of those ions matter. We decided our salt was acidic. you flip your paper back to the front side, you'll see that when we said when it was acidic, we want to use the cation. Okay, so because this was acidic, we are going to use the cation. Okay, so acidic, use cation. So now we can write our actual equation that would go in our table. So we're going to take just the cation, which is NH4 plus. Why are you angry with me, board? There we go. We're going to take the cation, which is NH4 plus, and we are going to react it with water. Okay, so take your cation and write H2O. And then double-sided arrow. This is your equilibrium. Okay, you're going to see now why NH4 plus is considered to be acidic. Now we've decided that our substance is acidic. And remember, that means this part, this NH4 plus, is acting like an acid. Acids donate H pluses. Okay, acids donate H pluses. So that cation is going to donate its H plus over to H2O. So if it donates its cation over to H2O, we get left with H3O plus. And then think about what NH4 plus looks like without an H plus. Now has gone back to just being ammonia. Okay, so NH4 plus, because it was an acidic salt, it was acting like an acid, we donated the H plus over to the H2O, leaving behind H3O plus, which of course is the same thing as H plus, and then NH3 was left off of the NH4 plus because we lost that hydrogen and that positive charge. Now this is the equation that would then go in your table that you would then do your problem with, cross this box off, and carry on, okay? But you have to be able to write these equations. So there's a little bit more to these salts than the others. Okay, let's try another one. All right, so we have NaBrO. Okay, so first thing you have to do is figure out whether or not the salt is acidic or basic. So NaOH and then HBrO. So NaOH is a strong base. HBrO is a weak acid. So strong base, weak acid gives me a basic salt. Okay, once I know that my salt is basic, then I'm going to carry forth with just the dissociation. Remember, the dissociation of the salt is complete. When you put a salt in water, it breaks up completely. The issue is that one of the ions will then react with water, and that will be the equilibrium. So this is going to break up completely in the Na plus and then BrO minus. Now we decided that we had a basic salt. Flip back to the front of your paper. We said when we have a basic salt that we will end up using the anion. So use anion. Okay, and this is how I suggest you put your work down. Just something really simple like this. Make yourself real simple notes. It helps a lot if you don't want to get lost in what you're doing. Okay? After you've done that, now it is time to actually use that ion and write the equation that matters. Okay, so now you're going to take the only ion that matters in this basic salt, which is the BrO minus, and you are going to react it with water, so plus H2O. You're going to use a double-sided arrow. Okay, double-sided arrow. And remember, we said BrO minus is acting basically. Okay, it's acting in a basic way, which means it is going to take an H plus. Okay, if you haven't written that down somewhere, remember, acids give away H pluses, bases take H pluses. Acids give away H pluses, bases take H pluses. So this one's acting in a basic way. It's going to take the H plus. Again, you can shove it wherever you want. I guess I should probably, it doesn't really matter, but I guess I'll stick with what I've been telling you and put it on the end. I more wanted to do it this way, to go back to its actual conjugate acid, which is HBrO, but regardless, either one of those is fine. I don't really care which way you do it. And then if you think about this H2O, if you gave up an H plus, you now have OH minus left over. Okay, and again, look, you made OH, and you said it was basic. That makes sense. Go back to the problem before. We said it was acidic, and if we scroll down, we made H3O plus, H plus. So they should make what they're telling you they are. If they're acidic, they should make H+. If they're basic, they should make OH-. Okay, so that's the basic idea of what we have going on. A couple more examples. Let's just go through those and see how you're doing. Actually, what I'm going to have you do is, let's take a look at this one. I'm going to have you pause the video. I want you to start by deciding if this thing is parent acid, is what the parent acids are, and whether or not this salt is acidic or basic. So pause the video, do that, and then unpause. So KOH is a strong base. And then this came from CHO2, so that is a weak acid. So this salt is a basic salt. Since it's a basic salt, we're going to go back up. Regardless if it's acidic or basic, we have to do this next step, which is breaking it up into K+ and CHO2-. But because it was basic, basic tells you to use the anion. So now go ahead and take the anion and write an equation of the anion reacting with water. Go ahead and pause the video and do that, and then unpause it. So we're going to have CH2O- reacting with H2O. We said it was basic. Make sure you have a double-sided arrow. It's basic means it's taking an H+. You don't have to actually draw that little arrow, but I'm just trying to demonstrate for you. Throw the hydrogen on there. Again, I don't care where it goes, front, back, wherever, as long as you've got it on there. We had a negative charge before, so now with the positive, that'll even out the charge, and we have an extra hydrogen on it. And then OH- as the anion. Okay. The other ion, I should say. So again, notice the production of a base. Now some of you are saying, all right, well, it made OH-, but it also made an acid. So why is this thing basic salt? Well, remember, this acid it makes is extremely weak. Extremely. So although there might be a little bit of dissociation going on, the OH- is going to dominate that. I mean, OH- is a fully basic molecule, and H+, those things have such an impact on that pH that it's not going to matter. So again, at this point, we would draw our table, which we will do in our next lesson, and go through this whole process. Okay, but today is just about figuring out the equations. All right, let's go to this next problem. I'd like you to pause it and try to do the entire problem from top to bottom. Now, if you get stuck, you can go ahead and play it again, and you'll be able to see I'm going to go through the entire problem. But go ahead and hit pause, and then come back when you're done. All right, so the first thing we need to do is decide if it's acidic or basic. So we take the NH4OH and realize that that's a weak base. We take HNO3, and that's going to be a strong acid. Okay, we look at those two. This is telling us acidic salt. Okay, acidic salt. So we're going to take and dissociate our ions. So break this up into NH4+ and NO3-, like so. Acidic salt tells you to use the cation. Okay, you definitely need to learn that. Okay, acidic uses the cation, basic uses the anion. Okay. So we're going to use the cation. Take that cation, and let's write an equation. So NH4+ is the only part of the salt I care about. It's reacting with H2O. Double-sided arrow. It is acidic, which means it will donate its H+. Acids give away H+, bases take them. So it's going to give it away. That's going to leave behind NH3. And then when you give an H+ to an H2O, you end up with H3O+, which again, of course, is the same thing as H+, but we really should write it in these equations as H3O+, because this water is over here on this side, and if we don't, then our equation won't balance out properly. Okay, and then put your table around, and you're ready to rock and roll with your Ka or Kb. Okay, so to do these problems, it takes a little bit more work. You're going to get good at it, though. You'll get to the point where you won't have that much need for thinking too hard about it, because you'll get more proficient at it. Just remember, the very first part is to decide whether or not you're dealing with an acid, a base, or a salt. So acids start with H. Okay, that's how you're going to know you have that. Salts have the metal, non-metal combination, and then don't forget that ammonium is an exception to that. And then bases are going to pretty much be everything else. And in your homework that you're going to be working on, you're going to have a bunch of different random compounds. So you're going to have acids and bases and salts all mixed up. And first thing you're going to have to do is decide whether or not it's an acid, a base, or a salt. And again, all three of them are on there. So you're not going to do this whole process on every single homework problem. You only do it on the salt problems. So it might be a good idea to start by first identifying whether or not the substance that you're looking at is a